Hello everyone, my name is Pablo Bort and I'm a software engineer at ETRA and also part of the ODEON project. Very nice to meet you. In this video, I'll walk you through how the community portfolio management and elasticity-based demand response tool works. It is one of the ODEON Energy Services for local energy communities and aggregators, built upon the foundations of energy data spaces. This innovative tool gives local area communities operators a holistic, data-driven view of their networks. It clusters users' flexibility and profiles, forecasts demand generation, and optimizes their participation in energy markets, all through ODEON's cloud-edge platform, which brings together decentralized data into intelligent ecosystems. But this is just one of our tools. You can find more information about ODEON solution at odeonproject.eu. So let's jump in and see how it works. Alright, let's log into the platform. Game on. We are now on the overview page. Here you can see the predicted energy demand and exports for the next 24 hours. On the right, there's a pie chart classifying community members by elasticity, socioeconomic profiles, and energy usage. We'll dive deeper into that later. Still on the overview page, here the system calculates the optimal dynamic tariff, adjusting for deviations between predictive models. Don't worry, I will explain that in more detail in a bit. And here's where it gets interesting. Optimization of the energy sold across the available markets. Again, more on that soon. Now we move to the portfolio pattern forecast engine. This page visualizes exported and consumed energy in real time, with forecast and historical data that you can browse by date. It handles short-term forecast, 24 hours, and long-term forecast, up to 3 years. And all this data can be exported as CSV files. Basically, it lets the community operators see at a glance how much energy is being produced, and how much can be sold into the different markets. Next up, portfolio profiling. This section clusters community users into 4 groups, A, B, C, and D, based on 3 key properties. Elasticity, meaning how users react to price changes. Temporal energy usage, how and when they consume electricity during the day or week. And socioeconomic features, such as age group, rural or urban area, household size, or contract type. Each property has its own set of clusters, grouping users with similar behavior. And the graphs below show member numbers and consumption per cluster. And in the socioeconomic view, you can even select users individually for direct comparison. Now, let's head into the wholesale market participation decision support system. Sounds static, right? Here we can see how the system handles deviations between forecasts made 24 hours ahead and those made just 6 hours before. It then suggests a dynamic tariff that helps balance these deviations by adjusting users' energy usage. The model includes 4 sections: historical deviations, showing past portfolio errors; intraday deviations, showing 2 days differences; optimum dynamic tariff calculation, which compares forecast deviation above and below with the ATL price needed to correct them; and the dynamic tariff price simulation, where we can run scenarios to test different tariff models. Finally, the market positioning optimization page. This one maximizes the commodity's profits by deciding how much energy to sell in each available market, which are day ahead, intraday, and intraday contiguous. It also displays key economic KPIs showing the benefits in each market type.